Alright guys, so we're going to try number 3 right now, which is finding all solutions of cosine x plus 1 equals sine x on the interval from 0 to 2 pi. So that's including 0 but not including 2 pi. So if we get one of the solutions renders 0, we would use that instead of 2 pi. Alright, so first thing, when we look at this, thinking about example 2 that we just did, I can't substitute in for either the cosine x or the sine x to get them into the same trig format because neither of these are squared. So next option would be, let's square them. So let's square both sides of the equation. So squaring, don't tell me that that's cosine squared plus 1. Because when you square, you gotta write it twice. And we're gonna FOIL that side out. So it's gonna be cosine squared plus 1 cosine x, and 1 cosine x is 2 cosine x. And then last is plus 1 equals, and sine squared. Okay, so the majority of them are in cosine form, so we're going to look on this right-hand side of the equation and change this sine squared into, our Pythagorean trig identity tells me that sine squared is equal to 1 minus cosine squared. And so then on this side we have cosine squared x plus 2 cosine x plus 1. Equals 1 minus cosine squared. So now we're going to bring everything to one side and then kind of assess the equation from there. So we're going to add cosine squared. So I get 2 cosine squared x, and I'm going to subtract 1. So I get plus 2 cosine x. These ones cancel, so I get equals 0. All right, so now I look at this and I say, all right, they have in common a 2 and a cosine x, so I can factor out that 2 cosine x, and I'm going to be left with just 1 cosine x plus 1 equals 0. And so once I have that factored, I can set each factor set equal to 0. So 2 cosine x equals 0, and cosine x plus 1 equals 0. And then I solve for cosine x, so cosine x equals divide by 2, 0. Cosine x equals subtract 1, negative 1. So now this is rewinding back to the unit circle, and we say, where does my x value equal 0? And my x value equals 0 at 2 locations on the unit circle, and that is pi over 2 and 3 pi over 2. So we have 2 locations from that solution set, and where does my x value equal negative 1 on the unit circle? And that's at pi. So this equation has 3 solutions, and it is pi over 2, 3 pi over 2, and pi. Now, here's one of the key things that we need to keep in mind from Algebra 2 is that if you introduce squaring to both sides, then we need to check all 3 solutions to see, do they work in your original equation? Because if they don't, then we're going to have to disregard them, because when you square, we might inadvertently add extra solutions that might not work to my original equation. All right, so we're going to check and make sure that all 3 of these are actual solutions that work to my original. So plugging in pi over 2, we get cosine pi over 2 plus 1. Does that equal sine of pi over 2? So we've got cosine of pi over 2, that's 0, plus 1. Does that equal the y value at pi over 2? which is 1, so that works. So this one works. So then we check 3 pi over 2. Does cosine of 3 pi over 2 plus 1 equal sine of 3 pi over 2? And so that's the x value at 3 pi over 2 is 0, plus 1. Is that equal to the y value at 3 pi over 2? Uh-oh. So that doesn't work. So we're going to actually get rid of this solution because it doesn't work with my original. And then my final one that I check is pi. So I'm going to do cosine pi plus 1, is that equal to sine of pi? So x value at pi is -1 plus 1, is that equal to my y value at pi, which is 0? And that works. So after squaring both sides, we have to check to make sure there are no, and this is a terminology you might remember from Algebra 2, extraneous solutions. So squaring, it adds in an extraneous solution of 3 pi over 2, so we're going to cancel that one. All right, guys, so that was a little tricky one.